Okay, so let's continue rationalizing. Okay, similarly, rationalize the numerator or denominator, make sure you check to see which one is asked you to do. But in this case, right, we're going to be rationalizing the numerator, and notice that in the top that there's not a single term, right? We don't know how to get rid of those square roots necessarily. So let's go back to something that we actually did before. And really what we have is a problem that looks like this, right? And what we're doing is we're multiplying something to it. And in order to get rid of a square root, we need it to be times itself. So we need to end up with something like that, right? Where this first part here ends up here, and this second part here ends up in this second part. So what type of formula did we have previously, where we have a problem where we have this multiplication ends up with something squared, something squared? Well, you should remember that that's the difference of squares, right? Or it should look very similar to that. So what we really want is a subtraction there. And the difference of squares tells us if that's a subtraction, that one must be a plus. And all of these are the same. Right? So the blue one is going to be the same all throughout, and the green one is going to be the same all throughout. So what we want to multiply this thing by is going to be the same thing but with a plus in the middle. That's called the conjugate. So this right here, A minus B versus A plus B, these are conjugates of each other. Okay? So anytime you want to find the conjugate, you change the middle middle operation into plus or minus depending on what it originally is. Now, it doesn't just have to look like this. So what I mean by that is you could have something like 3x plus 2 plus y squared, and you can group it like that, and its conjugate would be that one. So what you're really doing is grouping it into two parts where the middle sign is going to change, versus this one over here, that's conjugate is going to be 3x minus 2y plus, 2 plus y squared. Okay. So conjugation is really grouping it into two parts and changing the sign in the middle as plus or minus. So let's go ahead and use this property, this conjugation and the difference of squares, to go ahead and solve these problems. So on the top, we want to rationalize the numerator. So to rationalize it, we need to find the conjugate of that. So x plus 5 plus square root of x. Anything I do to the top, I also do to the bottom. And because we know that this conjugation multiplication turns into a difference of squares, we can automatically write it as the first one squared minus the second one squared. And the denominator is just the product of the conjugate and 5. So this makes it really easy, right? Because the squares cancel. And you're just left with x plus 5 minus x divided by 5 times square root of x plus 5 plus square root of x. And then these over here, the x's, they also cancel. So all you're left with in the final answer is just 5 divided by 5 times square root of x plus 5 plus square root of x. And then if you want those cancel as well, and you're going to be left with a 1 on the top. So similarly with that problem, except this time we're going to rationalize the denominator. So the denominator here has a minus, and what I'm going to multiply the top and the bottom by is going to be the square root of y plus 3 square root of x. And anytime we do it to the bottom, we do it to the top as well. So what we get is 3 square root of x plus the square root of y times square root of y plus 3 square root of x. Since the bottom is the one that we rationalized and we're taking the product using the conjugate, then we get the first one squared minus the second one all squared. And then copy the top. And then evaluate this as y minus 9x. Because the square goes there as well as that. So we get 9x. And that is your answer. And the reason it's your answer, again, is because the question asks you to rationalize the denominator, not simplify it.